Welcome to the class of medical physics. In this lecture, we are going to discuss about the radiation protection methods. What are radiations? What type of radiations? Where do we get these electromagnetic radiations? And what are the protective methods to save one from those radiations? So first of all, what is radiation? All matter is made up of atoms, each consisting of a nucleus containing the neutrons and positively charged protons. Negatively charged electrons surround the nucleus. The nucleus of radioactive atom has excess energy, causing it to be unstable. To become more stable, the radioactive nucleus will eventually release energy after going to deformation in the form of either particulate, that is alpha or beta particle, or electromagnetic radiation, that is the gamma rays. So in either form, those radioactive elements degrade themselves to become stabilize their nucleus, to become stable, to come into stable form, and to release their instability, right? So these are radiations. Radiations are the result of basically instability of radioactive elements towards the stable states. Energy emitted from a body or source that is transmitted through an intervening medium or space and absorbed by another body. These radiations are highly absorbable when transmitted into one body to another. The transmission is in the form of waves, but wave particle duality under quantum physics. They have both wave and particular nature. Just keep that in your mind. We have discussed so many times about that what is the nature and behavior of those electromagnetic radiations. So just keep that in your mind that radiations, that is gamma rays, they have both wave nature and they have particle nature as well. So energy has both wave and particle property. When these forms of radiation strike atom of any material, they may have enough energy to eject electron. Of course, this process is called ionization. What is ionization? When uh, you provide energy to a certain atom, and that energy is strong enough or high enough to strike atom out of that material. That energy basically provide energy to the electron present in outermost shell, and after gaining that strong energy, that electron become highly energized and become an independent electron as in the form of free electron or free radical, and comes out of or you could say it leaves the okay, so that electron basically comes out of the atom, and is this process is known as ionization. Ionization can result in breaking of electron bonds that hold atom together. Ionization and other radiation induced effects such as excitation and free radical formation, which causes chemical changes in components of the living cell, including your DNA. Your DNA get disturbs. This is a famous thing that your DNA get disturbs or alter when you absorbs these kind of radiations of X-rays and gamma rays. So it directly affects your DNA, the genetic material in the cell that is located in chromosome within the nucleus. Radiation is also classified as being either non-ionizing or ionizing. This is one maybe something new to you people, that ionizing radiations are of both types, ionizing and non-ionizing. Obviously, ionizing radiations are the hazardous one. However, the non-ionizing radiations are less harmful to no harmful at all. Non-ionizing radiation is has longer wavelength because they are present at the greater wavelength end of electromagnetic radiation, which are your microwave and radio radio wave end, right? Because they have higher wavelength and lower frequency, and so lower energy, because energy is associated with the frequency. The more the frequent any movement is, the more they have energy possessing property, right? So while ionizing radiation has short wavelength, high frequency, so they have ultimately high energy radiations as well. Ionizing radiation has sufficient energy to produce ions in matter at the molecular level. If that matter, if that matter is a human, significant damage can result, including damage to your DNA, denaturation of proteins. This is not to say that non-ionizing radiation can't cause injury to humans, but the injury is generally or restricted only to thermal damages such as burns, superficial burns, we could say, but they don't cause damage to your DNA. What? Your non-ionizing radiations. There is a great deal of information on the above chart. Okay, the below chart for, sorry. There is a great deal of information on the chart given below. One of the most interesting thing is that the visible spectrum is essentially divided between non-ionizing and ionizing radiation. You can clearly see into that. Some part of ultraviolet rays, which is more tilted towards the higher frequency range, are ionizing part, and after all that ultraviolet range, the whole series of electromagnetic radiation comes into ionizing domain. However, the long wavelength or the wide wavelength ultraviolet end lie or tends in your non-ionizing category, and from this to the other end of electromagnetic spectrum, which is radio waves and microwaves, they all lie in your non-ionizing type of radiations, including the infrared, microwave, radio wave, and extremely low or high wavelength rays. They have optical, they have thermal and non-thermal effects depending upon their wavelength and frequency. It will indicate that depending upon their wavelength and frequency, whether the wave is harmful enough or not, right? So one of the most interesting thing is that visible spectrum is essentially divided between ionizing and non-ionizing radiation. This makes sense clinically when we think of UV radiation causing skin cancer, because UV radiation has impact, a direct impact on skin cancer, and cancer is one of a type of ionizing ionization result. So UV radiation does possess the property of causing ionization in the body, so that it can cause the skin cancer as well. Next is types of non-ionizing radiation and their clinical effects. Non-ionizing radiations come in the form of radio frequencies, microfrequencies, lasers, infrared, visible spectrum, and some section of ultraviolet rays. This list is in order of lowest to highest frequency, radio frequency, and microwave frequency exposures. Okay, from where you get the exposure of those frequency radiations. Radar and communication systems, industrial and commercial applications, cell phones are reasons for causing radio and micro exposures. Their clinical effect includes, okay, before that, they have a great deal of controversy regarding the potential cancer risk, and it is still under observation of the researchers whether they can cause the cancer risk or not, or are they prone to cause cancer or not. Particularly with cell phone use, we know that the exposure to radio and microfrequency sources can cause burns, and clinically this is what you are most likely to see. Next are your laser, the light amplification by stimulated emission of radiation. The full form of laser is light amplification by stimulated emission of radiation. They are the beams of coherent light with single wavelength and frequency, that they may be IR visible or UV spectrum. Eye is most sensitive to injury from lasers, the most sensible area. 4 classes by risk of injury includes They could cause damage or no damage. They have low chance for damage due to blink. Third one is it could cause injury with direct exposure, cause injury even when reflected. Number fourth is requires control to prevent injury. Infrared. Uh, Infrared penetrates superficial layers of the skin, causes the thermal injury, potential for damage to the cornea, iris, and lens of the eye. It comes from in the when you go for welding, glass making, heating, and dehydrating processes. Next is your visible spectrum, another category of non-ionizing radiations. It says uh, it consists of wavelength range of 400 nanometers to 750 nanometers. They have red, orange, yellow, green, blue, and indigo violet number of colors of wavelength. Possibilities of retinal injury ranges or lie among the range of 400 to 500 nanometer wavelength, which is somewhere between the blue frequency ranges. Ultraviolet radiation is in the form of wavelength range of 200 nanometers to 400 nanometers. Now you can see that range is going to be decrease in terms of frequency and wavelength when it comes to ultraviolet from visible spectrum. It is a bridge between non-ionizing and ionizing radiations because they have both ionizing and non-ionizing impact. Three regions are there according to their the said ionizing and non-ionizing property. UVA, UVB, and UVC. You can see they are only differentiated in terms of their wavelength ranges. A and B bands produce biologic effect on skin and the eye, photocratics, conjunctivitis, sunburn, photosensitization reaction, and skin cancer. Majority of exposures are to outdoor workers that are being exposed to sunlight for longer time duration. Other exposures include for welders, people who work in drying and curing industry and laboratory, kitchen or medical industries exposed to germicidal ultraviolet light. Types of ionizing radiation, the hazardous one and their clinical impacts. Ionizing radiation is emitted from radioactive atomic structure as high energy electromagnetic waves, gamma and X-rays, or as actual particles in the form of beta, alpha, and neutron particles. Gamma rays, X-rays, alpha particle, beta, and neutrons. Penetration of radiation include gamma rays, X-rays, and neutrons penetrate body easily. They need lead to shield for gamma and X-rays, massive shielding for neutrons, however. Simple is that gamma rays, X-rays, and neutrons, all of them are such high hazardous radiation that needs a proper shielding in order to control the people present in the arena of those radiation. In order to save them, a proper shielding is highly required. Alpha and beta particles are essentially blocked by the skin, with beta particles penetrating more deeply with the potential to cause burns, whereas alpha particles can be stopped by paper, beta by plastic. So they could be stoppable by paper and plastic. Alpha particles can cause significant damage if taken internally. Common occupational exposures. These are highly important to be considered. Medicine in radionuclides and X-ray and all the focal person involved into them. Nuclear power industry in document dating, in food preservations, airplane space flights, transportation of radioactive material. Another one most harmful field of working. Next is the quantities and associated units of radiation. Radiation measurement, radiations are measured in röntgen, describes a radiation field in terms of the amount of ionization produced in air, not in common use today. That was being defined or standardized on the basis of amount of ionization produced in the air. Red comes from radiation is the conventional unit of absorbed dose of radiation per unit mass, like per unit of mass of let's say human body are absorbing how much amount of dose of those radiations. Next is gray. One gray is comprises of 100 reds. What is REM? Absorption measure to whole body or a specified organ takes into account radiation quality. What was the quality of those radiations? Are they concentrated enough? So REM could be measured, REM could be measured by multiplying the reds with the quality factor of those radiation. Each type of ionizing radiation has a different quality factor. Sievert, one sievert comprises of 100 REM. Ionizing radiation exposure limits for occupational or focal persons. National Council on Radiation Protection, NCRP, annual exposure could be 5 REM. Background exposure for a US resident is 360 REM. What are internal and external hazards that could cause by radiations? 4 ionizing radiation exposure categories or categorized into radioactive contaminants on intact skin, local radiation injury, whole body exposure, internal deposition. Acute syndromes from those radiations include over 100 rad is in a single exposure or within 24 to 48 hours after the progressive predictable series of signs and symptoms developing over a period ranging between a few hours to several weeks. So these acute and chronic syndromes caused by by continuous exposure of these radiation could cause some serious and harmful impacts on focal persons as well. Clinical response and prognosis generally depends on damage sustained by the hematopoietic system. Lethal dose for 50% of healthy human is in between 350 to 450 rads or 3.5 to 4.5 gray. Prodromal period is 1 to 6 hours after exposure. Anorexia, nausea, vomiting, diarrhea, these are initial symptoms. Subsidize after a few hours to 2 days. Ominous sign including the diarrhea, skin arrhythmia, lymphocyte count when they go below 1000, short or non-latent period. So what is latent period? It is variable in duration, hours to 30 days. Manifest illness include the fatigue, GI symptoms, desquamation, deep ulceration, bone marrow depression, stomatitis, hemorrhagic phenomena, and all that. Are they curable or they could cause death? Again, it depends upon the number of exposures one get affected by them. It could be find out like CBC normalizes whether in 6 months to a few years. So according to that, or the clinical recovery if it is occurring within 6 months or if it is persistent fatigue. Long-term effect includes the chronic radiodermatitis, cataracts, sterility, perinatal effects, cancer, and genetic effects. Short lifespan or shortened the lifespan, the whole duration of one's life is also counted as a long-term effect. Okay. Next topic is the main principle to control external hazards. These includes your distance, how much distance should be maintained when exposed radiations are being exposed, how much time for how long the radiation could be provided, and how much shielding is necessary to save the persons present in vicinity of that equipment or that source of radiations. So there are three primary means of reducing radiation dose from sources external to the body, that is time, distance, and proper shielding. Time: for a given source of radiation, the amount of radiation energy deposit in body is related to how long one is exposed to them. Therefore, reducing the duration of an individual's exposure to radiation will decrease the dose. Distance: increasing the distance between an individual and a radiation source is an important mean of reducing the radiation exposure, because the intensity of the radiation is inversely proportional to the square of the distance from the radiation source. This has been previously discussed in the lecture that intensity of radiation or any electromagnetic light spectrum is inversely proportional to the square of distance from that source. Either it is ionizing or the non-ionizing, both. So for example, when the distance from a localized source is doubled, the intensity of radiation is reduced by 1/4. Next is shielding. Shielding is useful for absorbing radiation energy if enough interactions occur in the shielding material. Then much of the radiation is prevented from reaching the body's tissue. Alpha particles can be stopped by a piece of paper, like beta particles are blocked by about a centimeter width of plastic. Clothing and outer layers of skin cells provided some protection from beta particle outside the body. So beta and alpha particles are not that harmful and can be easily stoppable. However, gamma rays may require many centimeters of lead shielding or meters of concrete for shielding. So concrete and lead are the mixture which is required for shielding of those ionizing radiations. Once a radioactive material is taken into the body, the protective measures of distance and shielding cannot be applied, because once it has been penetrated into the human body, it is unstoppable. However, the duration of internal exposure may be reduced by increasing the rate of excretion of the radioactive material through elimination of body's fluid or solid. If it is possible to excrete out those radiation through body fluids or solids by means of medications. The primary mean of protection from internal radiation exposure is to prevent radioactive materials from entering the body in the first place. So appropriate respiratory protection can prevent the inhalation of airborne radioactive materials. Ingestion is prevented by not eating, drinking, or smoking where radioactive materials are present. So you see, there are lots and lots of ways to get exposed by those radiations, not only through skin, by all your open areas, through ingestion, through respiration. So these are highly harmful enough, and these are highly hazardous to be affected or exposed by those radiations if you are present in the vicinity of any such radiation source. Okay, so this is up to this class. Hope everything is clear to you. See you in the next lecture. Thank you.